Hello y'all, we are Memphis Community University and today we're covering another calculus done wrong lesson where we wrong calculus before calculus wrongs us. And today what we're going to be doing is we're going to be talking about asymptotes. So even if this is in our basic derivative topics list, this is actually a limits topic, but I don't think you're going to complain. Let's cover asymptotes today. Today we're going to be talking about two main asymptotes. These are the two main asymptotes that appear on the AP exam as well as college calculus exams. Those are going to be horizontal asymptote and vertical asymptote. And what we're going to do is we're going to try to focus on the theory of these things because sometimes that appears in the multiple choice. We're not going to cover oblique asymptotes or slant asymptotes because those don't usually appear on the AP exam. We're going to focus on the ones that actually do. So let's start with horizontal asymptotes. Those are the harder ones. And then in the second half of the video, we're going to talk about vertical asymptotes. And then we'll wrap up the discussion by talking about both of them. So first off, what we're going to do is we're going to talk about horizontal asymptotes. So horizontal asymptotes. Again, this is a limit topic. It's not even a derivative topic. So you might have covered horizontal or vertical asymptotes in a pre-calculus class or something like that. But remember what a horizontal asymptote is. What number does a function tend when x goes to infinity or negative infinity? So as you're plugging in multiple bigger and bigger and bigger and bigger x's, is your function tending towards a number? And if it's so, that's going to be your horizontal asymptote. So what I want to focus on is the definition of a horizontal asymptote. So to find the horizontal asymptote, which I'm going to abbreviate as HA, to find the HA of a function, what you want to do is you want to take two limits. So right when you see the words horizontal asymptote, you just set up two limits and you just do those two limits. So the limits are limit as x goes to infinity of the function, because you want to see what happens when you keep going further and further and further and further. And the other limit is the other direction. So we're going to see what happens when we go this way. So it's going to be limit as x goes to negative infinity, f of x. So this is what you do. See the words horizontal asymptotes, find this limit, find this limit. There's no such thing as setting the top to be 0 or taking a derivative and setting that to be 0. It's not the same thing as horizontal tangent line. Unfortunately, they both share the word horizontal, but horizontal tangent line is finding where the slope of the derivative equals 0. But this is purely a limit question. Find this limit, find this limit. So that's what we're going to do with our examples. Keep in mind that we talked in a previous video extensively how to find limits as x approaches infinity and negative infinity, especially the ratio of two polynomials. That video was called Limits Involving Infinity in our Limits and Derivative playlist. In that video, we talked about a process called heaviness, where to take the limit as x goes to negative infinity or infinity of a polynomial over a polynomial, you look at the leading terms and you compare the exponents of the leading terms. And you'll see that we're going to do that currently. So hopefully this will be a nice review for you if you haven't watched that video. And then hopefully you can learn something new. But for now, let's get started. Let's find some horizontal asymptotes. I'm getting a little bit too excited. I'm going to try to do this, and then hopefully once we have learned horizontal and vertical asymptotes, we will have earned ourselves a nice little nap. So let's look forward to that. But for now, let's do some questions. So what we're going to do is we're going to find the horizontal asymptotes of the following three things. So find the horizontal asymptotes. Again, right when we see horizontal asymptotes, we know that we're going to be setting up limits. So find the horizontal asymptotes of this function right here. So we're just going to take this, let's take it as 3x squared plus 2x, and then we're going to have 6x squared minus, 1. And then we're going to have the second function. So we're going to do three questions in one, but we're going to compare them. That's why we're doing them in a trio. So we're going to have 6x, just 6x on the top. And then finally on the bottom, the hardest one, we're going to have the numerator have the bigger exponent. So we're going to have this as 6x cubed minus 1 over 3x squared plus 2x. So again, in these questions, the only thing that's changing is the leading power, because that affects the heaviness as we talked about earlier in our previous video. But if you didn't watch that video, it's going to be fine. So again, right when you see the words horizontal asymptote of this function right here, you set up two limits. So because I've done this before, I know that the two limits are going to be the same number. If you want, you can always find the limit as x goes to infinity, and then you can find the limit as x goes to negative infinity. If they're the same answer, that's great. That means that's the answer. If you have two different answers, that's also perfectly fine. It means you just have two different answers. But because I need to conserve space here, I'm going to do the limits at the same time because I know that these two limits will give me the same answer. For this last one, I know that the limits won't give me the same answer, so I will do them separately. But if you want to do it always separately to do the same thing every time, don't feel too bad about that. So in this case, what we do is right when you see the words horizontal asymptote, you set up two limits. We're going to do it all at once, so we're going to set up really one limit and two. So we're going to go both infinity to negative infinity. Right when you see the horizontal asymptotes, just do this limit right here. And hopefully, if you saw our video, you sort of remember this. When you're going to infinity or negative infinity, again, you look at the leading term and the exponents of the leading term. So in this case, the leading term is 6x to the squared. The biggest power is squared. Same thing on the bottom. The biggest power is 2 on the bottom. So those two things are equal if you look at 2 and 2. So 2 and 2. That means that we are dealing with something that's same heavy. When you have something that's same heavy, what you do is you ignore all the things that are not these leading terms. And when I talk about leading terms, I mean the biggest exponent. If this were written as minus 1 plus 6x squared, the leading term would still be 6x squared because that's the term that has the biggest exponent. Usually it's written in order, but even if it's not written in order, it's still easy to find the leading term. The term with the biggest exponent, both in the numerator and the denominator. So because these are the same, x squared over x squared, this is same heavy. So this is going to be same heavy. And when you have same heavy, what the answer will be, both of these limits, what it's going to be is the ratio of the coefficients of the leading terms. So in this case, it's going to be 6 over 3. So the answer is just 2, 6 over 3. And again, we're dealing with horizontal lines. That's going to be our horizontal asymptotes. So the most correct answer, the answer you would see in a multiple choice is y is equal to 2, because this is how you express horizontal lines. So again, anytime you're approached with a question of horizontal asymptote, just set up the limit as x goes to negative infinity. You don't have to worry about the words for your horizontal asymptote anymore. Just find these two limits, and that's going to be your answer. The next one is even easier. When you set this up, it's going to be limit as x goes to positive and negative infinity. So it's going to be 6x squared minus 1, or this is just 6x, so there's no more squared here. 3x squared plus 2x. Again, anytime you're going to infinity and negative infinity of polynomials, you can ignore the non-leading term or the terms that aren't the biggest and the exponent. Just ignore those guys. Just focus on the main culprits here. So the main culprits are going to be 6x and 3x squared. What is the comparison of their exponents? Well, this one is 1. The bottom is 2. So that means it's bottom heavy. The bottom dominates this fraction. Bottom heavy is the greatest thing in the world because, as you can remember in our limits involving infinity video, these answers are always 0. So because we have something bottom heavy, that means that the answer is going to be y equals 0. The x-axis is going to be the horizontal asymptotes. So finally we come to this guy. This guy is going to be top heavy. When we set up this limit, because we have a 3 and a 2, 3 I believe is bigger than 2, 3 bigger than 2. So in this case we have top heavy. Remember, top heavy is the trickiest one because you have to determine whether it's infinity or negative infinity. So let's do that real quick. So we have limit. I'm going to write both of these because I'm going to write them separately because, again, I'm aware that there's going to be different answers. So 6x cubed minus 1, but the minus 1 really doesn't matter. 3x squared plus 2x. And then let's write it over here. Limit as x goes to negative infinity. Same thing. Again, if you want to approach this strategy with the previous examples, just keep rewriting these limits. Just write this limit and this limit separately, and you should be good to go. 1 to infinity, 1 to negative infinity. So again, these are top heavy because the 3 is bigger than the 2. The 3 is bigger than the 2. If I can change this to a 2, because that's what it is. So these are going to be top heavy, so we can write the words top heavy. So remember, the limit as x goes to infinity of a top heavy thing is either infinity or negative infinity. So what you do is you plug it into the leading exponent. You ignore all the smaller terms. So let's ignore all these smaller terms. And what you do is you just see whether you get positive or negative stuff. So when you plug in a positive thing or a positive quantity, a giant positive number into this x, everything is going to remain positive on this side. You're going to have a positive or a positive. So this answer will be infinity. Then limit as x goes to negative infinity. What you're going to do is you're going to plug in a massive negative number or a negative number that's great in magnitude, like -1,000,000, -1,000,000,000. You're not actually computing the number. All you're determining is whether you get a negative or not. When you plug in negative infinity into the cube, the negative remains because -1 to an odd power is still -1. And the denominator, -1 squared, the negatives will cancel out, which is great. So it looks like we're going to have a negative over a positive, and a negative over a positive and negative. So in this case, we are going to get the answer negative infinity. Great. So again, horizontal asymptotes are of course horizontal. So if you don't get numbers, that means that you just have no horizontal asymptotes. This function does not tend towards a number as you go towards infinity, as you go towards negative infinity. So this is just going to be no horizontal asymptotes. So this is just how you do these questions. You have these functions here. You set up limits as x goes to negative infinity and infinity. Sometimes you can do them both at the same time if you've done a lot of these sort of questions. Same heavy, look at the ratio. Bottom heavy, the answer is 0. Top heavy, usually the limits will not exist. As x goes to infinity and negative infinity, you're going to get negative infinity or infinity, which means that you won't get a number. Those won't have horizontal asymptotes. And there's other reasons why something might not have a horizontal asymptote. For example, sine of x, even if it keeps hitting 1 and -1, it never tends towards those lines. So the function sine of x doesn't have a horizontal asymptote. But let's practice with harder horizontal asymptote questions, the ones that give my students the most trouble because they sort of haven't been refreshed on how to do limits as x goes to negative infinity and infinity. So I'm going to do one of those. So I'm going to erase this. I'm going to erase this guy. I'm going to erase. So there are some questions where it is very, very prudent, or it's a good idea to actually write these two limits separately because you might get actual two different answers. And that's going to occur in our square root same heavy questions that we talked about earlier in that limits involving infinity video. So in this case, I'm going to try to find the horizontal asymptotes, of course. Horizontal asymptotes of this function right here. Square root of 25x squared minus x over 4x. Let's do 5 minus 4x or something like that. So again, right when I see this question, I'm doing horizontal asymptotes. They would say the students find the horizontal asymptotes, blah, 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 of this function. So what we're going to do again is set up two limits, one to infinity, one to negative infinity of this function. Then we won't have to worry about the word horizontal asymptotes. We'll just find those two limits. So in this case, it's going to be limit as x goes to infinity of 25x squared minus x over 5 minus 4x. So I set up this limit, then I'm going to set up the other limit, and we're going to find both limits, and then we'll be on our merry way. So in this case, we have limit as x goes to negative infinity, 5 minus 4x. So close to our nap that we're going to earn after this video. So let's just keep going. Let's keep going strong. So in this case, let's take this positive infinity one first. Just do the two limits separately. So if you remember, again, what you're doing is you're ignoring the non-leading terms, or the terms that aren't don't have the biggest power in both the numerator and the denominator. In this case, it'll be the minus x, and in this case, it'll be this 5 because x has a bigger exponent, as the exponent 1. So remember, what is square root of 25x squared really, really similar to? Well, it's really, really similar to 5x. And then what's on the bottom? Let's put an approximate actually. What's on the bottom? Notice that this is going to be minus 4x. So which one do we have on our hand? Well, we have same heavy, top heavy, or bottom heavy. This is going to be same heavy because they're both like x's. Square rooting x squared is really similar to an x. So that's why it's going to be same heavy. So this answer is going to be negative 5/4. But remember that as you're doing these questions, you do really want to be careful with those negatives. So for example, I'm going to talk about how to do it. It's the same thing with that top heavy example. Just remember that when you square something and then you square root it, you will get the same thing back, but you might lose your negative. So for example, if you take the number -4, if you square it, you'll get 16. If you take the square root, you'll get 4. So you don't end up with the thing that you start off with, you end up with actually the negative of the thing you started off with. So just be careful with those negatives. So in this case, when we plug in an infinity, you square root it, and you square root it. You square it and square root it. Sorry, I don't know what I'm saying anymore. So that means that you'll get a positive on the top. When you plug in infinity into the bottom, the -4x will dominate this +5. So you're just going to have a negative thing. A positive over negative is indeed a negative, so that's our answer. But this one, to negative infinity, is the same exact thing almost. You're going to get something like 5x over -4x. So you might be thinking, well, the answer again is 5/4. But again, we have to be careful with negatives. When you plug in negative infinity in the top here, again, we're ignoring this -x because it's not the biggest guy. We don't care about the biggest guy, we only care about the culprits of the thing. So when you plug in negative infinity, when you square that and you square root it, the negative goes away. So you're going to still be left with something positive on the top. But when you plug in something negative into the bottom, after the 5 goes away because you're getting bigger and bigger numbers, when you plug in negative infinity into the bottom, it'll be negative times negative. So it looks like, in this case, the answer will be positive as well. So that's why the answer won't match the answer from above. This answer is actually positive with 5/4. So again, we plugged in these negatives to see if, for these same heavy square root questions, so this is the same heavy square root questions, whether these answers were actually positive or negative. It is pretty easy. Just take the square root of the number 5, divide it by the coefficient of the leading exponent and the denominator, but then just plug in negative infinity to see whether you get a positive or negative number. All of that is to say that here we have two answers. Keep in mind that this is not two one-sided limits, so we actually do have horizontal asymptotes. You can have two horizontal asymptotes. In this case, our answer is going to be y is equal to 5/4, y is equal to negative 5/4, so it's going to be plus or minus 5/4. And that's it. So I know this video is dragging on a little bit. I'm getting a little bit tired. I'm really thinking about that nap, but I want us to succeed. So let's do one more horizontal asymptote question, and then we can move on to the far easier thing, which is vertical asymptotes. So again, one more horizontal asymptotes. Let's keep going very strong, and then we will earn our deserved nap. So let's get going. Let's erase this. So the next function I want to do is I want to do 3 minus 4 to the x over 4 to the x. No, let's not do 4 to the x. Let's do 4e to the x. And then let's do 2x e to the x. Sorry about this. Plus 1. So this is going to be the guides we're going to do. And again, what you do is you set up two limits, one to infinity and one to negative infinity. Right when you see the horizontal asymptotes, this is the most important thing of this video. Right when you see the words horizontal asymptotes, find these two limits, one to infinity, one to negative infinity. So in this case, we're going to set them up. 3 minus 4 e to the x, 2 e to the x plus 1. And then we're going to set up this limit as well. Again, in these harder cases, unlike our first example, it's nice to actually write these two limits and just compute them. So we're going to compute them. E to the x over 2 e to the x plus 1. So again, none of this changes. It's the limit themselves that are changing. So here we go. This was the second half of our limits involving infinity video, where we talked about being careful with infinities. When we have these e's, what we're going to do is we're just going to plug in infinity and just see what we get. Notice that when you plug in infinity in the top here, you're going to get 3 minus 4 e to the infinity. On the bottom here, my marker's running out, which is really sad, but hopefully we'll be able to survive. When we plug in infinity into the x here, we're going to get 2 e to the infinity. Well, e to the infinity is the same thing as infinity, because if you have infinity and you have e and you keep multiplying it by itself a bunch of times, you're going to get bigger and bigger numbers. So all of this is going to be infinity. It will be negative infinity. 3 minus negative infinity will still be negative infinity. So this is going to be negative infinity over, and on the denominator will be the same thing. If you take e, multiply it a bunch of times, and you multiply by 2, add 1, you're still going to get a huge number. So that's going to be infinity. Remember that if you have negative infinity or infinity, one way to do this limit will be L'Hopital's rule. So let's review L'Hopital's rule. If ever you get an indeterminate form, 0 over 0, or infinity, you're allowed to use L'Hopital's rule. So you take the derivative of the top, derivative of the bottom, and you see what you get. Then let's see what happens. So let's apply L'Hopital's rule. Let's lope that tall. So in this case, we're going to do this limit. Limit as x goes to infinity. The derivative of 3 is 0. The derivative of e to the x is the best function in the world. So it looks like we have minus 4 e to the x over 2 e to the x. Because the derivative of 2 e to the x is this thing, and then plus 0, because the derivative of 1 is 0. So if you know what you're doing, you're actually done. But if you don't know what you're doing, you'll actually get stuck in an infinite loop and we'll never get our nap, which would be very, very sad. But if you keep plugging infinity, you're going to keep getting negative infinity or infinity. And what you're going to do, your instinct is to L'Hopital and L'Hopital and L'Hopital and L'Hopital and L'Hopital, because you'll keep getting negative infinity or infinity. But as you do L'Hopital rules, you're going to get the same thing because the derivative is always itself. So you're never going to finish the question and we're never going to be able to sleep. But that's can be certainly avoided if you just recognize as you do multiple L'Hopital rules, as you take multiple derivatives, multiple integrals, one rule of thumb is to simplify as you go. So you can simplify these things pretty easily, and notice that we're just left with minus 2. So this is going to be our first horizontal asymptote, which was found using L'Hopital's rule. Because when we plugged in infinity, we got e to the infinity with L'Hopital. And as we L'Hopital ruled, we noticed that we can just cancel things out, and our final limit was negative 2. So let's try this limit, and then this will be the final horizontal asymptote question. So again, when we have these e's, it's a lot harder than saying heavy top, heavy bottom, heavy. Let's actually plug in the negative infinity, and let's just slowly manipulate it. So in this case, we'll have 3 minus 4 e to the negative infinity over 2 e to the negative infinity plus 1. From our limits involving infinity video, you might know what e to the negative infinity is off the top of your head, but if you don't, what I like to do is I like to think of it as a negative exponent, because it is a negative exponent. There's a negative. So I'm going to write it as 1 over e to the infinity. So it's going to be 3 minus 4, 1 over e to the infinity, over 2 times 1 over e to the infinity, plus 1. E to the infinity is infinity because, again, you're multiplying 2.7 by itself an infinite number of times. You're just going to get bigger and bigger and bigger numbers, so that's infinity. 1 over infinity, though, is 0, because if you imagine you have some sort of candy bar and you're splitting it up amongst a million people, a billion people, a trillion people, a quadrillion people, gillion people, then you'll see that 1 over that, every single person is going to get slightly smaller and smaller and smaller pieces until you get 0. So this term, 1 over e to the infinity, and both slots is going to be 0. 1 divided by a million, 1 divided by a gajillion is going to be 0. So in this case, all of this goes away, all of this goes away, and finally you're left with the answer 3. So here, the answer is negative 2. Here, the answer is 3. These are our two horizontal asymptotes. Let's write it on this side here. Negative 2 and y equals 3. Again, you can have two different answers because you can have two different horizontal asymptotes. One on this side, one on this side. We're all good. This is the answer. So again, if you're having trouble with these limits involving infinity, please watch our limits involving infinity video where we practice a lot of those. But for now, I can sense the nap coming. Let's do vertical asymptotes. Vertical asymptotes are pretty easy. So the reason why people think horizontal asymptotes or you set the top to be 0 is because of vertical asymptotes. So remember, horizontal asymptotes are by definition limit as x goes to infinity or negative infinity, but vertical asymptotes is you set the bottom to be 0. So for vertical asymptotes, what you should do is you're going to have a fraction just like normal. So you're going to have some sort of f of x function, but it's going to be two functions. Sorry, my pen is dying here, but hopefully I'll be able to live through this next few videos, or at least this next few problems. So what you do is what you want to do is you want to factor the numerator, factor the denominator, and cross out things that are in common. So things that are in common are going to be called wholes. So these are our wholes. Those are the ones that are going to be in common. Common factors. A fancy word for wholes that sometimes the AP exam uses is removable discontinuity. Whole is one of the most common types of things that are not continuous. You lift up your pencil as you draw them. They're called removable because you can easily remove them by filling it in, I think. And then finally, the actual vertical asymptotes. So the vertical asymptotes, you can do it, pen, you can do it. Asymptotes. These are going to be whatever is remaining in the denominator. So it's the zeros of the denominator after you cancel things out. Remaining, oh, I'm not going to be able to write this. I did not plan this out. Let's just write of denominator or demon or denom. So again, just factor the top, cross them out. Those will be the wholes. And then finally, your vertical asymptotes will be anything that is a zero of the denominator. So let's practice a few examples. Why don't we? These are pretty easy. So let's erase this. Not much to erase because it didn't write very clearly, but we're still going to soldier on. So first question is going to be f of x is equal to x squared minus 4 over, and let's see how good I am at math. Not very great, but who's sort of going to stop me still? Let's have, I believe, plus 2. So we're going to have this function right here. And now, instead of finding the horizontal asymptotes, if you want to check the horizontal asymptotes is y equals 1 because it's same heavy, we're going to find the vertical asymptotes. So the first step for a vertical asymptote question is to simplify. So in this case, the answer is going to be x, we're going to factor, not simplify. That is a way of simplifying. Talking to myself now. So it looks like this factoring is right here. And this factoring is right here. There's a difference of squares on the bottom. So it looks like we have canceled these two. So if you look at our denominator, we're going to have two different things. The whole is the one that canceled. So the whole is going to be x is equal to 2 because we canceled them out. What's going to be the actual vertical asymptote? Where is there going to be a vertical asymptote for our function? That's going to be what it remains in the denominator. So that's going to be x plus 2. So for example, our vertical asymptote, so we can just call it VA, vertical asymptote will be x is equal to -2. It's that simple. Factor both the numerator and the denominator. Things that cancel out are wholes. Things that remain in the denominator are vertical asymptotes. So this picture would look something, a vertical asymptote, if you don't know, I don't know what the exact picture of this one looks like, but a hole is literally you erase it and draw a hole. A vertical asymptote is you tend towards this. So this is what a vertical asymptote looks like. And that's it. So again, not very difficult question. Factor both the numerator and the denominator. Cross out things that are in common, wholes, and then finally what remains in the denominator is a vertical asymptote when you set it equal to 0. So maybe one more. Let's just do the function tangent x. Where are the vertical asymptotes of tangent x? Well, you first need to write it as a fraction. That's going to be sine x over cosine x. So where are the vertical asymptotes? The vertical asymptotes will be where, first we cross out wholes, but sine and cosine don't share any zeros, so there's no wholes to cross out. And then what's the remaining denominator? That's just cosine x. Where's that 0? That's going to be your pi over 2's, 3 pi over 2, 5 pi over 2, 7 pi over 2, same thing with negatives as well. So our vertical asymptotes are going to be pi over 2, 3 pi over 2, 5 pi over 2. The pi over 2's that don't cross out, like if not like, I guess odd multiples of pi over 2. Pi over 2, 3 pi over 2, 5 pi over 2. Same thing with the negatives. These are going to be our vertical asymptotes. And that really concludes our video. So we talked about horizontal asymptotes. Those are by definition the limit as x goes to infinity and negative infinity, where you do same heavy, top heavy, bottom heavy, and then you employ those rules to find the two limits. Just find those limits. There's no setting things to be 0. Find those two limits and you'll be good to go. Vertical asymptotes, check for wholes first by factoring and crossing out common factors. What remains in the denominator will be your vertical asymptotes. Just a few theory things here and there. For horizontal asymptote questions, let's try this. For horizontal asymptote questions, Remember that you can have at most 2. You can either have 0, 1, or 2, because you can have 1 for this side of the function. So this could be my horizontal asymptote, sorry, on this side, and then another horizontal asymptote on this side. We want to be a function still. So let's say we go like this. Let's say we come down here and go like this. So again, you can have 2 horizontal asymptotes because you have 2 different limits to compute. You can either have 0 because it's top heavy, you can have 1, like those same heavy, bottom heavy questions, and you can have 2, like those e to the x questions or the square root same heavy questions. So you can have 0, 1, or 2 horizontal asymptotes, 1 for each side basically. As we talked about with our tangent example, maybe cotangent as well, you can have an unlimited number of vertical asymptotes. You just shove more things in the denominator and more zeros, and that will create a vertical asymptote at that point. So that's one theoretical thing. 0, 1, or 2 horizontal asymptotes, any whole number, including infinity, including 0 for vertical asymptotes. Finally, you're not allowed to cross vertical asymptotes because it will break the function rule. So you have a vertical asymptote, you're not going to be able to cross this line. But for horizontal asymptote, because everything is in the nice direction, you are allowed to cross horizontal asymptotes as long as you eventually tend towards those functions. So that's basically it. Horizontal asymptotes, the main point of this video, set up limits as x goes to infinity and negative infinity, and then employ 7 heavy, top heavy, bottom heavy. If you want more practice with asymptotes, because it's pretty theoretical, if you want to compute some horizontal asymptotes, some vertical asymptotes, maybe even try some questions, some similar multiple choice questions, those theoretical ones that students have oftentimes a lot of trouble with, be sure to check out our Girls Teach Calculus video, which I'm linking in the description below as normal, where one of my former students practices these questions. We're going to continue doing derivative topics throughout this next few videos, so be on the lookout for that. Thanks again for watching. I'm going to go take a nap. Hopefully you'll be able to go take a nap. I'm sure it's going to be a lovely nap where we're going to just stream about asymptotes, how horizontal asymptotes are by definition the limit as x goes to infinity and negative infinity. I will hopefully see you in our next video. Thanks again for watching, of course. See you soon.